Hello everyone, welcome to my class. Hope you have learned all the concepts that I taught you in the last class. So today we are going to learn about D block elements and their characteristics. Let's start the class. D block elements. Students, don't you remember the position of D block elements? Yes, in the middle of S and P block, right? So, can you tell me from which period onwards does the D block begin? You are right. From 4th period onwards, the D block elements begin. Now, look at this table showing the D block elements in the 4th period. Analyze the configuration of the last two subshells, that is 3D and 4S. Is there any relation between group number and the total number of electrons in S and D subshell? They are same, right? For example, consider the element scandium. Its group number is 3. How did you get this 3? By adding the number of electrons in D and S subshell. That is, the group number of D block elements will be the same as the sum of electrons in the outermost S subshell and the number of electrons in the preceding D subshell. So, if you want to find the group number of D block element, add the number of electrons present in the S subshell and the D subshell. Is that clear? Okay. Now we will learn about the characteristics of D block elements. First point. 3 to 12 group elements are called D block elements, but they are known as transition elements. Why? Because here the last electron is entered into the D subshell of the penultimate shell. Hence they are called a transition metal. Third point. They show variable oxidation state. And you have learnt about the oxidation state in 9th standard. Oxidation state refers to the number of electrons lost or gained or shared by an atoms during the chemical bond formation. The oxidation state are of two types, fixed oxidation state and variable oxidation state. Some of the elements show fixed oxidation state. Listen, you have to by heart this table, then only you will be able to do some calculations later. And D block elements show variable oxidation state. See the examples. Look at the names and chemical formulae of two different chlorides of iron. You have to find the oxidation state of iron in these compounds. Students, don't you remember the rules about the oxidation number that we learned in 9th standard? That is, the oxidation number of atoms in any free uncombined element is 0, and also the sum of oxidation numbers of all atoms in a compound is 0. So in FeCl2, the oxidation state of iron is +2 and in FeCl3, the oxidation state is +3. How did you get this number? We know for unknown element, we give the number x. So consider the oxidation state of Fe is equal to x. And also we know the oxidation state of chlorine. Since there are two chlorine, we can write x plus minus 1 into 2. The sum of the oxidation numbers in a compound is 0. So just equate the equation to 0. We get x plus minus 2 equals 0 and x is equal to +2. Similarly, for MnO2, here Mn is considered as unknown element. So give the number x and the oxidation state of oxygen is -2. By applying the rule of oxidation state, we get x is equal to +4. Is that clear? Now you got the oxidation number of Fe and Mn, right? Now, how will you write the configuration of these ions? Look at this example. The configuration of Fe is argon 3d6 4s2. So, what is the configuration of Fe2+? It is argon 3d6. Do you know how did we get this number? Remember, while writing the configuration of ions, the electrons are not lost in the same order as they are filled up. Actually, the electrons are lost from the outermost S subshell first. So what is the configuration of Fe3 plus? We know the configuration of iron is argon 3d6 4s2. If Fe becomes Fe3 plus, the configuration is written as argon 3d5. That is, 2 electron is lost from the s subshell first and 1 electron lost from the d subshell. Do you know why do these d block elements show different oxidation state? It is because the energy difference between the outermost s subshell and the penultimate d subshell is very small. So under suitable condition, the electrons in the d subshell also take part in the chemical reaction along with the outermost s subshell. Hence, d block elements show variable oxidation state. This is the very important question. Once again, I will repeat for you. Why do d block elements show variable oxidation state? The energy difference between outermost s subshell and penultimate d subshell is very small. Under suitable condition, d electrons also take part with the chemical reaction. The next characteristic property is they form colored compounds. The reason for the colored compound is due to the presence of transition metal ions present in this compound. Let us see some examples. Copper sulfate, blue, potassium permanganate, purple, ferrous sulfate, light green, and manganese dioxide, black. These colored compounds have some uses too. That is, the compounds of transition elements are used for giving color to glasses and in oil paintings. So students, let's review what we learned today. Group 3 to 12 elements are called d block elements and they are known as transition elements. They exhibit variable oxidation state and also they form colored compounds. Here is an activity for you. Choose the right statements which are applicable to d block elements. And also, find the oxidation state of following compounds and write down the subshell electronic configuration of Mn. Thank you.